All right, this is Honors Algebra 2 Pre-Calculus, and we are doing 6.3. This is our second video. We're talking about logarithmic functions. So the inverse of an exponential function, like y equals 10 to the x, is x equals 10 to the y. But if we rewrite that solving for y, we get y equals log base 10 of x. So logs are the inverse functions of the matching exponentials. Cool. So you can actually see that if we look at this table, right? So if we look at 10 to the x, there's an existing table that shows you what 10 to the x would be from -3 to 3 for those integer values. And then we can see log base 10 of x if we plug in those y values that we got, right? If we switch the x for y, and you'll see what a log base 10 looks like and what an 10 to the x looks like. As with all inverses, the graphs of these two images are flipped over the line y equals x. So you can get an idea for domain and range here. Remember, in previous videos, we've talked about the domain and range of exponential functions, right? Exponential functions have a domain of all real numbers and a range of all positive real numbers, meaning greater than 0, right? So therefore, the log base 10, or any log, has the reverse domain and range, right? So it has a domain of only the positive numbers and a range of all real numbers. So that's the idea with this log function. So the log base b of x, right, is the inverse of y equals b to the x, all right? And a one-to-one property, and we're going to talk about this with both logs and exponents, is that if you have b to the x equals b to the y, then you can assume that x is the same as y. So for instance, if I told you that 2 to the 5th was the same as 2 to the 3x, I could assume that 5 was equal to 3x, and x is 5/3. All right, so in example 1, we're going to find the value of v in each equation. So most of the time, this is going to relate to rewriting things in exponential form because you can see these start in log form. So let's start with a. If I rewrite a in exponential form, I'm going to get 125 raised to the v equals 5. But here you need a little bit of extra knowledge, which is to know that 125 is a power of 5. It's 5 to the 3rd to the v equals 5. So 5 to the 3v equals 5 to the 1st, thus using that one-to-one property, 3v equals 1, v is 1/3. Okay, if we do the same thing for b, if I rewrite this in exponential form, I get v to the 5th equals 32, right? Well, 32 happens to be a 5th power. Now you could take the 5th root of 32, that's fine, right? Or you could notice that 32 is 2 to the 5th, so v has to be 2. The other way to get there would have been to say, hey, I'm going to take the 5th root of 32, which you do in a calculator by doing 32 to the 1/5, and you'd get v is 2. For the last one, I'm going to rewrite this in exponential form, and that's pretty much it, because when I rewrite this in exponential form, I get 3 to the 4th is v, so 81 is my v. Cool. All right, you're going to go ahead and give a P3 a try. So same idea, right? So for all three of these, we're going to rewrite them in exponential form, and that should help us find the value of v. So 4 to the v equals 64, but 64 is a power of 4. It's 4 to the 3rd, so v must be 3. Here we have v to the 2nd is a 25, so v to the 2nd is a 25. Right? Now you might be saying, hey, couldn't I solve this by taking a square root? So the trick is that the base of a log has to be positive and not 1. Right? So the base of a log is positive and not 1. So basically, while technically you could square root this and say, oh, hey, look, don't I get a -5 as well? You actually don't, because the base of the logarithm has to be positive. So it's not a plus or minus situation. It's just a 5. And then here, if we rewrite 3 to the 6th equals v, so 3 to the 6th equals v. So 3 to the 5th is a 243, right? So we should be looking at 729. So 729 is v, and there's certainly nothing wrong with putting that in your calculator. All right. All right, so from lesson 2.7, you'll recall that when we put a negative in front of a function, what it does is it flips it over the x-axis. So here's the log base 10 of x, and if we put a negative in front of log base 10 of x, we would just get a graph that flips over the x-axis, right? So the function y equals the negative log base 10 of x is actually used in chemistry to measure pH levels. The pH of a solution describes how acidic or basic it is. Substances that are more acidic have a lower pH, while the substances that are less acidic, which we call basic, have a higher pH. The pH of a substance is defined as pH equals the negative log base 10 of the H plus ions, right? So the H plus ions. And we're going to use this formula in the next two examples to calculate H plus ions based on the pH. So given that the pH of a substance is the negative log base 10 of H plus, what is and the pH of a carbonated soda is 3, the question is what is the H plus concentration, right? What's the hydrogen ion concentration for this soda? So 3 equals negative log base 10 of the H plus concentration. Right? I can't rewrite this as an exponential yet because I need to solve down to the log. So I'm going to get negative 3 equals the log base 10 of the H plus concentration. And now I can rewrite this and say 10 to the negative third is the H plus concentration. So I could leave it like that if you want, or you could make it a 1 over a 10 to the third, or you could make it what a 1,000th would be. Okay, so any of those would be fine. All right, go ahead and try a P4. Same idea, right? Now this time you're going to have to probably use a calculator because nobody expects you to be able to do a 3.75 in your head. So the log base 10 of the H plus ions, right? So the first thing I'm going to do is divide by that negative, right? I'm going to solve down to the logarithm. We're still doing SADMAP, right? We're still solving down to the thing that is an exponential, and logs just behave like an exponential. I'm going to rewrite this in exponential form. Again, you're definitely going to put this in a calculator. So this you're going to have to put in a calculator. We didn't have to do that with the last one, but here I'm going to have to do 10 to the negative 3.75. All right, and I'm going to get that the H plus concentration is, now this is a 1, so notice that this is 1.77827941 times 10 to the negative 4, so that's scientific notation. That means 1, 2, 3, 4. So this would be 0.00, so 1, 2, 3, right? So that's what you do with the negative fourth. So 1, 2, 3, 4. That's how small it is, right? So right? You could write down that it was 1.778 times 10 to the negative fourth as well, because that's what that is, okay? All right.